All right. There you go. Okay, now you can share your screen.
Okay. Hello, Farid.
Hello, sir.
Yeah, hello. Can you hear me?
Yeah, I can hear you, but your voice is a little bit low. So if you...
Okay. 1 second. Can you hear me now?
I can hear you, but still the voice is a little bit low.
Okay. So I had some questions for the, just check the file. For example, here, if you can see, for the one-line diagram, the HL panel, you multiply for the factor of 3 for the power like kVA per foot 3, but it's not an education place, it's a museum, so it should be multiplied by 1.6, right?
Can you say it again? Sorry.
For the HL.
Okay. That's for lighting, right?
Yes.
So
For the
what's the
lightning.
question?
Yes, for the lightning, you had multiply for the kVA, you have multiplied 3 by the total area of the building, right?
Yeah, that's according to NEC code. If you go to, let me give you the article. So according to NEC code for commercial building, that's 3 kVA. You take 3 kVA and multiply to the area of the building.
Yeah, I actually I need to fix it because this one is it's not educational. It's a museum, so you should multiply by 1.6.
But still, it's commercial, right? So if so we have two type of building or occupancy. One is residential, and the other is non-residential, which is commercial. So for that, according to NEC code, we will have to take 3 kVA, unless like you go by every single like facility, like room by room. So let me pull out that NEC code, the specific article, so you will see. Hold on, I will just pull out that.
Okay.
Yeah, but to change that, it's easy. Just change the number and everything will automatically calculate for you. But I just want to make sure like we're using the correct NEC code article.
Yes, yeah, I have to change it, but I just have the picture. I don't have the whole file, I cannot change it.
So if you go to article table 220.12, if you have NEC code, or you can just Google it online. So there are general lighting loads by occupancy. Or I can share you right now if you want. I can share my screen.
Yeah, you can share. I have to make you host or something.
Yeah, I think Sumit, can you?
Post sharing. Okay. Remote control. No, this is the control.
Let me send that in the chat room so you can see the table, please.
Okay.
I don't see your screen, Yusuf. Is that you have stopped sharing?
Yes, because Farid want to share screen.
I just want to show him Sumit that article.
Okay. Got it.
Can you make me host, Sumit?
Yeah, sure. Let me make you host so that you can share your screen. All right. You are the host now, Farid.
Where is that option to share the screen? Oh, I got it.
Yeah.
Can you guys see my screen?
Oh, actually, no, I can't. One moment.
Can you see?
No, I have. Let me join again. One moment. Yes.
Okay, so if you can see my screen, Yusuf, so this is the article for lighting, for
I,
PVC code.
I still
So you
cannot
can
see the screen.
You cannot see?
Yes.
You can see or you cannot?
No, I cannot
No,
see.
no.
Sumit, you also cannot see?
No, Farid. I can't see your screen. Maybe you need to stop share and share again.
Now let me jump off and then I will reconnect back.
All right.
Sumit, can you make me host again?
Yeah. Wait a second. Okay, you are the host.
Okay. Can you guys see my screen?
Yes. Yes, I can see the screen.
Okay.
Yes.
So as you can see, this is National Electrical Code, right?
No.
And then we have that article 220.12 for general lighting load by occupancy. So we took 3 kVA, right? Which is school.
Yes, but can you check the in the right side? Show a museum.
On this guy?
Yes.
But that's not referenced by electrical by NEC code.
Oh, okay. So what's
Yeah,
this?
that's something that I just copied, from somewhere else. But it should be IEC or some other reference like European standard. So there's a lot of standards like Asian have their own standard, but for if you are in US, so we have to follow NEC code. That's what they call it, National Electrical Code.
Okay.
So I mean, we can use this number, but your design will be not that accurate. So if you want to be have an accurate design, then reference NEC code. That's what we are doing. We are using in our design. So anyway, so you have two type of calculation in your design. Since you already place all your lighting, so your connected load is based on your quantity, the lighting which we already modeled in Revit, and that's connected. So but according to this 3 kVA, so we size the panel board, the cable, the feeders, the main breakers. It means that your panel and your feeder and breaker is more considered for the future also. Because right now, I'm sure if you compare this table, so same for receptacle, you have two type of calculations. So let me show you. So if you see here, B is for lighting, right? So the total quantity of your lighting in Revit file is 1137. And the voltage for all your lighting is 277. So if you use that article and then since it's continuous load, you take this number, multiply it with the voltage, and then multiply it with 1.25, which is 25%, since it's continuous load. So your lighting is operating more than 3 hours. So you have to multiply it with 25%. So if you check the B and come here down, you will see the calculation by details. So it starts from here, B. So references based on NEC code 220.12. So you take 3 kVA, that's one method of calculation. You take 3 kVA, multiply it by the square feet of your building, which is 35 kilo square feet, and multiply it by 1.25, which is continuous load. So this is the number. The total lighting load in your project is 131 kVA. So based on this one, we size the HL panel, that HL panel that you just shared. So that panel is sized based on this one, like the amperage, the feeder size, and the breaker. And then the other method is to take the quantity of the light that you already modeled. I just did the circuiting. So you take the number of lighting here, right, which is 1137, and then you multiply it by the amperage. That means each of your lights have a wattage. So you do the calculation by Ohm law or the Kirchhoff laws, and you find the amperage, and you multiply to the number of or quantity of your lighting, then multiply it to the voltage, and then multiply it to the 1.25, which is continuous load. So this number is the connected load. So right now, based on 1,137 light, you have 62 kVA. So this is the current situation of your lighting. That's the load. But it's safer to use NEC code calculation and size your breaker, your panel board, and your feeder size. Because NEC code is saying go with the larger number. But if you check in your panel board, in the bottom of your panel board, you will see this is the connected load. Let me open your project. So are you following what I'm saying?
Yes. The only thing I'm just confusing because it's not showing museum, and I thought you take 3.
Yeah, that one you can disregard. I just give you more resources, so in the future you can use this. Because if you see here, some of these occupancies is not covered here, like museum. But since your design is more like it should be everything should be perfect because it's your project, it's your students, so that's why you should have everything based on NEC code. So if someone asks you where you find this table, then you don't know the source. I mean, you can use it, but you don't know the source. So, but this one at least you can argue with them that this is the table number and this came from NEC code. HL panel, which is specifically for lighting, that 150 amp is based on that load, which So if you see, this is the load, but this is the connected load for lighting. But if you go with the ABC, that's 131 kVA. So your panel is based on this one. The main breaker is based on 131 kVA, and the feeder size, this feeder is based on that 131 kVA. Because if you take 55, that gives you this number, which is 150. What's the next question then?
Yes. For the receptacles circuiting, if you can show the receptacle circuiting, I don't know why it's not connected like same as the lightning.
Oh, you mean the circuit wise?
The receptacles, yes. Yeah, this one.
What do you mean, like why we don't show it like this wiring?
Yeah, like if you see the wiring for lightning, it's showing for like everything, but for the receptacle, I don't see wiring everywhere, you know.
Oh, you mean the home runs? This wire? Why is not receptacle everywhere? Right? This one?
Yes, yes,
Oh,
like
yeah. So still, there's two type of. I mean, it depends on the company. That I'm just sharing my experience. Sumit is also here, so he knows. So either you show this like this, the circuit number for every single receptacle, or you just show like the wire, the home runs. It's just an arc. You just have a wire, a line that it shows that these are connected in one circuit. So in your case, I just show both like I was not sure like which one do you like or which one your professor like. So you can use this way, showing with the wire connected to each other, or just show like receptacle panel and then the panel name and the circuit number. It means that this receptacle is fitting from LR and the circuit number is number 4.
okay.
So that's still connected. Everything is connected.
Oh, okay.
So it means that if this part is not showing the wires, it's still connected. So let me show you, like if you go to, if I select this, then go to LR, you will see that, or maybe I can do this way. Everything is connected. You click on this, go to electrical circuit, you see the second routine. But you can still do it.
So there is two methods for this one. I just know now. Yeah.
See, if it's not circuited, the derivative will not automatically draw for you this line. Just look at the scale. You click on the receptacle, just hover your mouse on the receptacle and then hit chat button in your keyboard, and then you see this wire arc will come. You click on it. That's it. You see these 4 receptacles or 5 receptacles on one circuit. You do the same here. So yeah, to answer your question, all receptacles are connected. And your total receptacle load is 78 kV. Does that answer your question?
Yes, yes. This will answer my question. For the configuration, you mentioned the report. It's all delta connection, right? Or
So yeah,
the,
that one, you have access to this project, right? You have the relevant one, right? So if you have the relevant one, you just hit ES like this, and then you go to the distribution system, or voltage definition. So you can see what's so you can see like what's the delta or what's the star connection. So in your case, you see like what voltage we selected. In the very beginning, I ask you like what voltage do you prefer? Like do you want your project to be 208 volt three phase or you want to be 480 volt 28 277?
So this the and the settings is it for the lightning and receptacles both, right?
Yeah, so if you go to like in the single line, so this is your main switchboard, and this is the voltage that uh, that's selected for your project. So your main MSB is 480 volt, 277 volt, which is delta connection. So if it's not delta connection, then this will be 3-wire, not 4-wire. You will not see the neutral. So you have 3-wire, phase A, B, and C, and then the fourth one is your neutral. That's why you have four W, which means it's 4 wires. You could also have another option that we discussed at the very beginning of your project. That before I started, I asked you like we can also have 208 volt slash 120 volt, 3-phase, 4-wire, like this one. You could have this one also. But that will change everything, like, because right now your all calculation is based on 480 volt, 277, because all your lighting voltage is 277 volt. So if you go with this guy, so you have to change all your lighting to 120 volt or 208 volt. So if someone is asking you, just tell them that your voltage operating system is 480 volt, 277 delta connection. And from this MSB,
yeah.
So based on the voltage, you select your MSB main rating, which is 600, and then you have two different type of panel boards. So you see all these HM, HL is 480 volt,
Yes.
277. So if you open any of these, like HM is that I call it HM because that H stands for high voltage and then M is for mechanical. So all your mechanical load is connected to HM panel and the voltage is 277 480 volt. And then HL is the same thing. That's dedicated for lighting and your voltage is 277 480 volt. And then you have two other receptacle panels, which is so mostly your receptacles are 120 volt. So you have to change your voltage. So for that you have to have a transformer that step down and change the form of the voltage from 480 volt to 208 120. So based on the load that we have for receptacle, we select the transformer, which is 75 kVA, and then that's change the form of the voltage, step down from 480 to 208 and 120, and then you get the 250 amps panel board. Since your receptacle is a lot, so you cannot end up with one panel, so you have another section of panel, which is LR1. So basically, you have one panel with 84 circuits. Two panels, either way.
Right. So you mentioned it's for the transformer 75 kVA. Like you mentioned last session that there is 250 ampere. It feeds the two panels, 150 for LR1, and
Yeah.
and for a transfer one, is it can be like 100 because 100 and 150 be 250.
No, because your load is a lot. If you check the 75 kVA, you remember like I give you a schedule. So there's a reference for if you go to 75 kVA table, it will dictate you like what will be the primary side breaker and the feeder and what will be the secondary for 75 kVA. So we cannot go just make it 100. So if you go to E4.0 or E4.1, that's why I give you this extra table for reference. So if you go to, so this first column is for 75 kVA for the transformer side. So if you go for 75 kVA, so the primary side is 100.
Oh, okay.
Primary side is your primary side is still 100 break, based on the table, and the feeder side is still 100, but the secondary is different. The next column is secondary. You follow the 25 kVA, come all the way up here. You see this is the 225 K1 will be your feeder side, which is two inch conduit, 2.5 inch conduit with 4x0 is your feeder side. If someone want to buy it, this is the size, correct size. And then you have the 225 is your breaker size, which is this one. That's the breaker size. Right? And then the ground is this one, number 2.
So the guide is a reference, right? The design guide, the schedule for design guide is a reference according to standards, right?
Yeah, this is standard. Yeah.
Okay.
You have when you see code 230 and 3, yeah, that's the large one. All these notes will tell you the reference.
Can you go to the copper feeder schedule, the right? Yes, for this one, the copper feeder schedule, I can see it. Also, is this you talked like last time that the standard size of breaker circuits from 20 to 4,000, and I know what's the simple, the conductors and the is it C? You said economy. What is the C?
Your voice is still very loud. I don't know, like, can you check your speaker and make your volume a little bit high?
Oh, 1 moment.
Last thing, Yusuf.
Yes, now can you hear me?
I can hear you, but still your voice is very low. Can you
Problem.
repeat it again one more time?
Yes, I might be have problem. How about now? Yeah, now it should be good. I think.
Okay, so just repeat your question. Let's see.
Yes. Is this like the as you can see it in the schedule, the feeder schedule? Is it all standards, even though the number for the MCM and is it like you use the reference or you just calculate it or how you get this numbers?
Well, this table is based on NEC code. So if you refer to that 310, you see that's everywhere, all around the world. So this is the NEC code 310.16 is the cable for conductor or for cable size. Even though if you go to online, just type 310.16, it will show you like what's going on here.
Yeah, can you go to that tape, please?
Yeah, and then all these figure size we just created. It's very useful for you also. We created this based on the amperage. It starts from 20 amps. And then every company have their own sample. You can show this like as a circle or whatever. We just show the rectangular with 200. So that two means that's the 20 amps. 20 is 20 amps. And then you have the conductive size. I explained to you last time maybe all these. And then you have 30, 40, like all this. These are the standard size of the columns, and then the conductor size of the conduit.
Yeah, what is C is economy? What is economy?
Right?
The economy.
Where is the conduit?
Yes, I don't understand this word economy. The C.
Oh, the C?
Yeah,
You mean in the notes here?
yeah, the C.
I think that's the temperature, centigrade.
Yeah. No, if you can see, if you can look up, like For example, under the conductors, you can see MCM number
Oh,
600.
this one?
Yes.
Oh, that's conduit. To the side of the conduit. The C stands for conduit.
Economy, like CONO. I don't.
Oh, this one?
Yes.
MCM?
Yes, you said economy.
Oh, that's yeah. You can do like this. It's for circular mirror, something like that. That's the the area of the conductor. You know. So this is equal to AWG or KCML or NCM. These are all the same. So, but I don't remember exactly what's it could be Miller circular something.
Yeah,
This is exactly that we have in metric system over there in ratio. So we have square feet. Like all the conductor sizes will be square feet. Like this way, let me show you. Yeah, but it's just the area of the conductor.
okay.
But you can find out like what MCM means. Like what stands for. Like exactly if you want to like know like what MCM means. Like Miller circular M something. You can find it in the NEC code.
Okay. Can you find me the reference for this all numbers? I want to see the like the NEC schedule or something.
So yeah, it's you see,
Yeah.
it's just a provision in circular length.
I'm setting.
MCM measurement. You can use
Can I see
MCM,
numbers
KCML, or AWG. All the AWG, I know that American wire gauge, they call it.
for the yes.
Wire gauge, MCM, KCML, all the same. Let's say that, or you can also use the millimeter, like the way that Asian use, you know. So here they use feet and inch, so we use like centimeter, millimeter. So these are all units.
Yes. Inch Khalid, can you show me the reference for all these numbers? Like I want to see reference
The transformers
no the reference for all these numbers that it's listed.
for the conductor.
Yeah, all the schedules, you know, I want the like yeah, this one, the conductors. I want the reference.
That's it. So if you go to the, so you just refer to each table, the notes, you see these sheet notes, so you will find out the reference. So for this table, the reference is 310.16. So if you just Google it, if you don't have the NEC code, just Google like table 310.16, it will show you the NEC code table. So this is all that the cable, the feeder and the cable sizes, and then it have a various type of isolation like TWH, TH, HW. The first one is the feeder size, and then you have the amperage. So the reference is 310.16 for this table.
Okay.
Right?
Yes.
And then you have like different resources. So you have for conductor, you refer to 310.16 for gram. This last column is the gram. So for that, you refer to 215.2. So you have different sources, but everything is here. So you can use it. Same thing. You can use this
Yeah, it's just simply all numbers. I cannot, you know, I cannot understand like how did you choose this number or calculate, you know, I don't understand, you know, because I'm not an
What's this extra thing that I give you? Like it's extra. You just your professor will know, like, you just tell him that based on the 310.16 ADC code you pick the conductor side. That will be helpful because you know that. This is extra that you created all you put up all these numbers, you create a schedule, you spend more time, and you create this. This is a very good difference for any project that you're going to work in the future. But if someone asks you how do you select the conductive side, the 310.16 just memorize that number because you will need this number in your going forward career. So this number will be enough. Just say that you pick the conductor base of 310.16. And then for the transformer, just say this.
Okay.
Does that answer the question?
Yes. Let me check. For you can notice like in the project you have one moment. Can I share my screen? Hello, and Farid. Can you hear me?
Yeah.
Yeah. Can I share my screen?
You want to show your screen?
Yes. Okay. One moment.
You want to share your screen?
Yes. Did you saw the analysis, the rendering, the sunlights?
Oh, yeah, that one. So we that was not part of our scope, but even though I did for you, you know. So if we talk in the very beginning, so you place the lighting. So I just placed the missing places like this area. You remember this area you didn't put the light. So and in spite of that, so I did all the lighting control for you. So I put the switches. You see, like this is three-way switch. So I believe, from my understanding, that rendering means that that's part of Title 24 requirements. So if your project is in California, so they have a Title 24 standard for the lighting that's similar to NEC code. So suppose like the area that have a sunlight, like the glaze or the window or the skylight. So in the roof there are some skylight. It's a window with a glass. So it meaning that the sunlight is coming into the room during the day. So for that, they use specific type of occupancies like motion sensors, occupancy sensors, based on Title 24 code. So for that, like for example, this room, you see there's this is a motion sensor or like a occupancy sensor. But if it's like this and then there is a glaze or suppose there is a glaze or window, so these lights should be turned off during the day automatically to save some electrical energy. So the idea is to save the
Okay.
money.
So the sensor will close the light automatically during the day, right?
Exactly, yeah. So it will.
I didn't know this point. Thank you.
Yeah, yeah. This is something that it's part of Title 24, and it's a very big discussion. So once you come to the work, you will see all these. Like this motion sensor is similar to that. So when someone like come and walk away here, so the sensor will sense the human body heat. So the heat that we have a specific heat, and then it will turn on all these lights automatically.
Okay.
Yeah. So this MD stands for motion sensor. And then you also have switches. Since you have four door, so you have three-way switches. So that three means there's a three-way switch. So you can turn off, you can turn on and off all these lights from this door. You can do it from this door, also from here. So that's also a standard. So if you have more than 4 doors in a corridor, so you have to provide a 3-way or 4-way switch. Besides that, you have a motion sensor.
Okay.
And then the other requirement, just for your information, that's part of Title 24. For any enclosed building or for any enclosed room, you have to have a switch. That's a must. So if you have an enclosed room like this, which is our boys' kits, so you have to have a switch. So if someone want to come, you have to use the switch for turn on and off the lights. So this was not part of our scope, but I add this for you. Like, so everywhere you see the switch, the motion sensors, and the exit signs. So the exit signs is also not part of our scope, but usually exit signs comes from architecture. So they will give you the egress path, like, meaning like this. For example, this is the exit path, so you can, if in case of emergency, you can use that path and go exit from that occupancy. So I did my best guess, and then you see, like, based on this path, you will see that this is the exit area. You will follow the exit, and then you go out from this door.
Right. For the last question, for the last thing, I did cost estimation for all the equipments, for the electrical equipments, and it's okay if you can just scan it like for only a few minutes, 2 or 3 minutes. If tell me what's more like I can add to the file, or what items I can like.
Okay, so did you cover like your major equipment, which is expensive based on your project, is the MSP main switchboard, 600 amps, then your transformer, and then your 4 panels. So this is the major equipment you should consider in your cost estimation. Plus your feeders, conductor or feeder sizes, and then you, of course, your receptacles. I don't know how many receptacles. So I think it's in the report. So total number of the receptacles.
Yes, I had considered all the receptacles.
So yeah, total you have 183 receptacles. So that's also should be adding your cost estimation, because I don't know, every receptacle is $10, $20, depends. And then same thing for your lighting. Have like almost 1,200 receptacles. That's also should be part of your cost estimation. There are different types of lights. Then you should cover the feeder size conductor. Make sure like these are the sizes. Make sure to add like the specific size of the feeders, because like the 600 feeder size is really expensive. So you have to consider it. What else?
I just type feeder size in Google and it will show the cost.
Yeah, that's fair enough. Just make sure the voltage and the feeder size. Then you will get the proper price.
And the feeder size according to the copper schedule, or like?
I think I also mentioned in your Word report that I share with you. Also, you can use this E4 sheet.
Yes, you can share.
I mean, I already shared with you, right? The Word file. So,
yeah.
So it's this guy. But you can use from here. So total feeder size that you use in your project is here. So you have 600. You have 400. You have 150, and then you have 100. And then these two guys. You have 1, 2, 3, 4, 5, 6. So total 6 size of the cable you have in your project.
6 size of cable. Okay.
Yeah. But if you want to be more into detail, you can add like 600. And then if you want to know what is the exact size of the 600, so you go here in E4.1. I told you all these, right? Do you remember like how to track or how to reference. So you go here, 600, 6004, and then if you want to Google it, Google this way. So your exact number, conductor size is 350 MCM. That's 350 MCM. And also you should have, like, you consider in your estimation, in your cost estimation, the conduit size. So you have two number of 3-inch conduit. At the same time, if you want to know what's the length, you have to refer here, like it's 70 feet. So you have to buy 150. So you see here 154. So you go here.
Actually, I cannot see the screen. Sorry.
Oh, sorry. I don't know.
Yes, now I can see.
Yeah, sorry. So I was just telling you, like, if you want to see, like, what's the 154 or 1504, so you go to E4.1, you check 154, which is this guy, right? And then
Yes.
you find out, you Google it, or you just ask some companies to ask them what's the cost for 1/0. So your size of the cable for 150 amps is 1/0, and then your conduit size, which this cable fit on that conduit, will be 1.5-inch conduit. So meaning that if you have 1/0 cable, and then you have to put it in a conduit, so the correct size for that cable will be this 1.5-inch conduit. So if you want to order it, so you have to know what's the length. So the company will ask you, what's the length of this 1/0, or how many you order, or how much, what's the length of the cable. So you go here in the E4 in this sheet, and you see that the length of that cable is 70 feet. This will affect on your cost estimation. So suppose you have 100 feet, that will be more expensive, right? Compared to you have 17 feet. How do you know that? You go to E6.0, you will see like your equipment is almost next to each other. That's why your feeder is short, not much. Suppose you have panel here, and then your transformer is all the way here. So that way your feeder or conductor length will be far. So between MSP and HL it's just 10 feet, 12 feet. That's why your cost will be less compared to if your equipment is far away from each other. Are you following?
Yes.
Yeah. You have 6 type of cable used in your project. So it's 150, 250, 100, 400, and 600. That's all feeder sizes that you use. And to reference it, you go here and see like what's the exact size of the conductor and the conduit. And if you want to know like what's the length of that, you reference here. So that's 20 feet. That's the voltage drop. The voltage drop will dictate for you if you size the feeder correctly. So if this is more than 2%, meaning that your feeder is not correct, so you have to upsize it to the next conductor in order to decrease the voltage drop.
More than 2%, because you have all under 2%. Right?
Yeah. So the idea is, if you open any panel, you will see that it's not here anyway. So the idea is the voltage drop in the feeder should be not more than 2%, and for the branch circuits should not go over 3%. Meaning like this all 1, 2, 3, 4, 5, 6, 7, 8, 9. So the non-receptacle is in one circuit, right? It's LR-4. So if you go to LR, in circuit number 4, so you have the 9 receptacle is connected in one circuit. So you combine 9 receptacle in one circuit. So if the voltage drop in the branch, this is called branch circuit. So if that goes over 3%, then you have to increase your feeder size from number 10 to number 8 or number 6. But for the feeder equipment, that they call it feeder. So between equipment, this is feeder. And then you like, basically in the real world, we have other branches coming out of these panel routes, right? And these are going to the different branch circuits, like the receptacles, the mechanical. So this feeder size, the voltage drop should not go over 3%. And this one should not go over 2%. This voltage drop. So basically, total should fall. So your total panel drop should not go over 5%. So 2 here and 3 there. Got it?
Yes. So 2% for the it's 2 and 3%.
Yeah,
So
3% for the branches.
3% for the branches, 2% for receptacles.
Yeah, you can call it 2% for the feeder, not
Feeder,
this.
feeder, feeder. For the feeders and 3% for percent. Okay. Yeah, I think that's all my questions for this session. I really appreciate it. Thank you so much for attending.
You're welcome. So I hope I do my best to pass the college, whatever you do.
Yes, I hope.
Sumit, are you there?
Yeah, I think I can leave now.
Yeah, so
Thank
good
you.
one. Yeah, thank you.
Thanks.
Sumit, are you there?
Hey, Farid.
Okay. So yeah, so I don't know if you hear. So Yusuf was.
Hey, 1 second, 1 second. Yeah, Farid.
He left, so I answered his all questions. So you can also, if you didn't hear, so you can prepare to the pre-call.
I can't hear you properly. What are you saying?
Call you then. Let me call you.
Okay, yeah. Just call me.
Yes, ma'am. Yeah. I don't have that energy to speak much, you know. It's better to call you through this phone, you know. Yeah, it's fasting, you know. It's hard. As much you talk, you know, it spends energy. Anyway, so Yusuf, I answered his all questions, so he was satisfied, and he is. So you can. Yeah, you can see it in the record. So he was appreciated the session, and he was very happy. Yeah. Yeah. So yeah, I think should be good for him. Because we gave him extra, man. Like we gave him extra. We gave him like the lighting controls, all the switches, the motion sensors. It was not part of our scope. Yeah, I know. Yeah, because. Right. Yeah, I mean, yeah, that's good. Yeah, that's great for him. But yeah, I believe we both tried to give him some extra since he's a student, and even the exit signs, everything, I give him extra, you know, like just to make his project perfect, you know. So he get the 100 number from his professor, you know. So Yeah, but the thing is, like, these people need like more electrical knowledge, design knowledge. So I mean, we can train them. That will be very helpful for them in the future.
Yeah, but you know that how the students will go like if I say now, okay, you guys need more training on electrical knowledge. He said yes, we are ready to do, but we not able to pay like blah blah blah. So I didn't want to spend waste my time, your time on these students because ultimately at the end they're not gonna pay that much. So I don't want to go into that direction.
That's
That's
exactly.
why like project wise whenever any student comes, I'm not interested that much because I know that they will not gonna pay as compared to what we are getting it from the corporates.
Right.
So if we are having a corporate, they will pay a good amount of the projects, but as a student, that will be completely different.
Exactly.
The only thing which I'm gonna interest more on, okay, you looking for a training in software.
Right.
Let's say I need a Revit electrical training, Revit mechanical training, or different software training, I'm happy to give him a student training.
Right.
Your training is a different situation where you are training the software. Project is like more detail wise.
Yeah. Yeah. It is
But
good.
that needs, yeah, and that needs a different rate. But the student will not understand that what they said. Oh, please understand here. So I was like, okay, whatever.
Yeah. We just did both, like for blessing and also for business, not only for business.
Yeah, exactly. I just for helping it, I said, okay, I will do it in this amount and just for years because you are a student. Otherwise, if it is a corporate guy or anything, that will be 10 times more than what you are getting. What
Yeah.
you are paying me right now.
Like a spring,
So I
like
said, yeah.
like Toll is charging Spring $85 per hour for these kind of projects. I just find out. Yeah, I just find out. And then they yeah they did, yeah, they crazy people, man. They charge my hours $85, man.
So see, that's what they
Yeah.
are charging 85%. They are gonna pay you. I don't know how much you're getting it, but from my understanding, I was getting like 30 to 50.
Same thing for me. Same thing, like from 85, like something like 40. Yeah.
So
Yeah.
see, more than 50%.
Yeah.
They are earning. They should earn like 20, 30%.
Yeah, it's not fair.
50,
Yeah.
75.
Yeah, as you said, like
That's why I didn't like the way.
yeah,
they
like
are doing.
as you said, like 30% margin profit is enough for a company. Like that's maximum. 30% is enough.
Yeah, it's everywhere it's like they put
Yeah.
that thing that
Yeah.
they are taking the fees of 45% and 75% in mine.
Right.
Okay, that's fair because it's not like they are going to get more than 50% increment.
Yeah.
But they're just getting a, they're just getting a project, but the rest of the things I have to.
Yeah.
They should have to give us more than 70% and they should take 20-30%. But that's why I don't like these targets.
Yeah.
Right?
Yeah. They're not fair though. I mean,
They're not fair.
totally.
So did you get raised? I think you asked for raise, right?
Yeah. So they just gave me in the last 2-3 years just $2.
Is it?
Yeah. I think it was at the same time that they gave you and you and me discussed this, right?
Like 2 years back, you got it?
Yeah. I mean, no. I mean from the day one till you are there, right? On those days. And they give you also a raise of 3 or 2 something, and then they gave me also same $2. But at the same time, Ashkan also gave me like $3. So 2, 3, $5. So I didn't ask for Ashkan, so Ashkan gave me. I mean, it was not my request or it was not Tal, right? So it's Sprig that they satisfy with our work, and they gave me also $3. And then asked Tal to give.
That $3 is a wire Tal, right? It's a separate extra from.
No, it was extra, like 3. Ashkan gave me $3, and then they also added $2 from Tal. So total 5 for them.
Okay. $5.
Yeah. So that
When they give you.
you were there on that time. I remember we discussed. I think you forgot.
No.
Yeah. You were there.
Yeah. But
You were there, and then
it's like last year.
it was this year January. I think you also told me that you got some raise like $2 something or $3.
January this year. See, this year January I resigned. My last day was December. So January I don't know whether
Oh yeah, then yeah, then maybe I'm missing. Because I remember you told me. Yeah, after 2 years.
So it's like almost how much? Almost 1 month, $800 you got a raise, right?
Yeah, but that's like, after the deduction, it's like, since I'm single, it's like $550 something. Yeah. Every month, Sumit, I'm paying like $3,000 to the federal, total, like federal, state tax, that social. So it's total.
$3,000 you're paying the taxes?
Yeah, every month. It's from my paycheck. $3,000 is going directly. Like, I can tell you the number exactly. $1,200 going to the federal, like $500 to the state tax, social security. It's crazy.
Oh, that's a huge amount.
It is.
Like, I think so you're getting like $6,000 or $7,000
Yeah,
salary.
yeah, and then
With $3,000 you're paying the taxes. That's a big amount.
it is, yeah. So if you have kids, you know that the rule here. So if you have kids, if you marry, then that amount tax amount will decrease.
Yeah. So now it's the benefit you will next year. From next year.
Yeah, let's see. I have to produce like twins kid.
Yeah, definitely.
Yeah. Yeah. So,
Okay, anyways, once you get married, I just hear the pics, marriage pics.
sure. We will have a meeting, and then you will share in the video. You will like, I will introduce my wife to your family and to you guys. Yeah, man, like it's a lot of expenses. Believe me, so much. It's a lot of expenses. My account is going to zero.
I've been in that situation.
Yeah.
I've been in that situation for the last 5 years. That's why I do each and everything. Expensive wise, and then fucking, the California thing is.
Yeah, but Sumit, if you do marriage, if you buy golds, man, that's a different thing. Man, like gold jewelry. Yeah, like I'm telling you, like if you spend like $20,000 in India or in Afghanistan, you can do like 3-4 marriages. But here, like you just buy like a few jewelries of gold. That's it. Yeah. Really expensive. Yeah. If I knew it, I wouldn't do it.
You're spending money also on your marriage, right?
Yeah, I did. Even though so let me tell you, like $22,000 I spent already in my engagement just for jewelry. Yeah. Yeah, man. Yeah.
And that's, let me ask you, is that the only the groom needs to spend the money, or the bride side also they are going to spend money on you? Or
So basically in our religions and our tradition, right? So both of these. So can you stop this recording? Maybe it will record our talking right now.
no, we are on WhatsApp call. We are not
But
Zoom call, so it's not.
yeah, but I have it open. Let me stop, and in my screen I stop.